In this session, we're going to talk about limits. Now, this is the introductory part to calculus. Okay, so we're talking about limits and continuity of a function. Okay, we're just from doing functions, but now how do we connect the two? So you must know that a limit is just the value that a function approaches as the input, or what we call the x value, or the independent variable, gets arbitrarily close to a certain point. Okay, and the way we're going to denote the limit, let's say the limit of, let's say of f of x, probably as maybe x is approaching a certain value. Okay, let's say x is approaching maybe 2. Okay, so this will be the denotation of a limit. Okay, now there are different types of limit that you're supposed to know. There's what we call a one-sided limit. Okay, there's what we call a two-sided limit, and there's what we call an infinite or an infinite limit. Okay, so these are some of the limits that we have. So what does a one-sided limit mean? It means you're approaching an x value or an input value from one side. Okay, then on the other hand, a two-sided just means you're approaching this x value from two sides. Okay, that is very important for you to know. Then an infinity limit is where just approaching these x values both from the negative infinity and to the positive infinity. Okay, let's give an example. Let's say this is our Cartesian plane, y-axis, x-axis. Let's say you have a point 2, and let's say you want this point. You want to approach that point, and let's say this point is 4, and let's say our function in this case, let's say our f of x is equals to, let's say, x squared. So when we put 2 in this function, you know that we are going to get a 4. Okay, so this is the point. Now let's say this was a quadratic expression. It passed through the mid, it passed through 0, 0. This was our graph. Okay, then that point. Now you can either approach this limit one-sided. Okay, you can come from this area, you approach that point following the graph. So this will be one side. Okay, it will be one-sided if you're just getting that root. Then you can also approach it from the other side like that. It will still be one-sided. Okay, now if you're approaching the limit on both sides, let's say you're approaching it this side and this side. Okay, this will be two-sided. Okay, so that's what we're talking about. Then on the contrary, let's say you have a graph. This is the x and this is the y. Okay, let's say now you're approaching 0. Okay, now you can either approach 0 in that direction, not not even getting close to the the x-axis, or you can also approach it in the other direction. Okay, so these values are going to positive and negative infinity. So these are infinite limits. Now, just to explain on the previous one, we've said you can approach a limit from two-sided, and those are the kind of the limits that we're going to be talking about. Okay, so let's say you have a number line, and on this number line, let's say this is 0, and the point, the input value that you are approaching, let's say you're approaching 2. Okay, this is our point. Now you can approach these 2. If it is a number line, you can approach it coming from the negatives, approaching 2, or you can also approach 2 coming from the positive, going to where 2 is. Okay, so now you're able to see that this is the negative and this is the positive. Okay, so how are you going to write that? The way you're going to express that is if you're going to find the limit, you're going to say the limit let's say of x squared as x is approaching 2, let's say from the positive side. Okay, and you can also approach 2 from the negative side. The limit of x squared as x is approaching 2 from the negative side. Okay, now if the limit approaching x if the limit of x squared as x is approaching 2 from both the negative and the positive are equal, if both of these ones are equal, then it means the limit exists. Okay, the limit exists. Okay, so what do we mean? Whether we put -2 or 2, wherever we square that, we still get 4, and you're able to see that all these answers are giving us 4, because as you're approaching, you know, this point 2 from the negative side, it is going at a point 4. Okay, same if you're approaching 2 coming from the positives, it will still, you're going to still get to this point 4. So because all of them are leading to one answer, this limit exists. However, there are some scenarios where limits don't exist, provided, you know, the limit of x, you know, the limit is not equal on both sides. So that is very, very important for you to know. Now let's talk about some of the fundamental rules, or let me just call them basic rules. Fundamental rules of limits. Okay, for you to be able to solve limits, there are certain rules that you need to understand. Okay, so let's call this one as rule number 1. Okay, so when you're finding the limit of a constant, let me say the limit of k as x is approaching, let's say it's approaching a. So, and k, therefore, this, in this instance, k is a constant. Because k is a constant, or it's a number, the limit in this case will be equals to k. It will be equals to the constant. An example that I can give on this one, let's say the limit as x is approaching, let's say 9. Let's say we're finding the limit of, let's say 60. Okay, in this case, because you're approaching a constant, okay, and you're finding the limit of a constant, so our answer will just be 60. Anytime you're finding the limit of a constant, the answer, it is that same constant. So that is very important for you to know. Then if you're finding the limit of a letter, let's say the limit of x, let's say as x is approaching, let's say a. So because x is a letter in this case, or let me say variable, okay, you are going to get a and replace where x is. Okay, let's say you have an example, the limit of x squared, let's say x squared as x is approaching, let's say a 2. So where there is 2, where there is x squared, you're going to be replacing, where there is x, you're going to replace 2. So you're going to have 2 squared. Okay, and 2 squared, that is just 4, and this will be your answer. So this is very important for you to know. Now, what if when you're adding and subtracting limits, what are you going to do? So rule number 3, what if now you're finding, let's say the sum and the difference, the sum or the difference of a limit. So how are you going to do that? Okay, so how you are going to find this one would be the limit, let's say the limit of let's say we have an expression, you're adding, let's say f of x, you're adding, now because the sum or difference, let's put them together, minus g of x. Okay, let's say as x is approaching a. So your answer in this case will be, you're going to find the limit of f of x as x is approaching a. It will be positive or minus the limit of g of x as x is approaching a. So this is how you are going to solve your limits. Okay, very simple and straightforward. What if you are finding now the product? Okay, allow me to call this one 2. What if you are finding the product of a limit? How are you going to do this? Let's say you are finding the limit of okay, the same f of x. Let's say now you are multiplying, because product is multiplication, right? G of x. Let's say as x is approaching the same, let's say a. So in this case, you are going to have the limit of f of x as x is approaching b, or let's say it's approaching a. This will be multiplied by the limit of g of x as x is approaching a. So you're just doing the multiplication of the two. So that is very important for you to know. Then you can also find the one for a quotient. Now you know that a quotient is just a number that you find after dividing. Okay, so how are you going to find that? So you're going, let's say you have the limit of f of x divided by g of x as x is approaching, let's say, the same a. So what are you going to have? You're just going to have the limit of f of x as x is approaching a divided by the limit of g of x as x is approaching a. Now in this case, let's say you find the limit on top to be, let's say, x, and you found that your limit down is y. So in this case, your y should not be equals to 0, because this whole expression will be undefined. Okay, so that is very, very important for you to know. Now let's solve some examples based on the rules that we've discussed so far. How do we apply these ones? Let's say you have a limit, let's say of let's say 5x plus 7 as x is approaching, let's say, 5. So I'm going to solve this one. Okay, so we're going to do the limit of 5x as x is approaching 5 plus the limit of 7 as x is approaching 5. Then you just solve. So now if you have a constant like 5x, you can take the 5x, the 5 to be here. So what we are going to have now is, you're going to have 5, the limit of x as x is approaching 5, plus then the limit of a constant. 7 is a constant, so the limit of a constant, it will just be that same constant, which is 7 in this case. Then how are we now going to solve this? Then you know that if you have the limit of a letter or a variable, in this case we have x, so we're going to replace x with the number that we're approaching, the x value that we're approaching, which is 5. So we're going to have 5, where there is x we're putting 5, plus a 7. 5 multiplied by 5, that is a 25, okay, plus a 7, okay. In this case, you're just going to have a 32, okay. So that will be your answer. Let's have another example. Let's say you're finding the limit, let's say, of 5x over, let's say, x squared plus 1, and you're approaching, let's say, x is approaching as x is approaching 2. So how are you going to find this? Okay, likewise, you're going to say the limit of 5x as x is approaching 2 divided by the limit, you know, of x squared plus 1 as x is approaching 2. Okay, so if we are going to solve this one, what are we going to have? I'm going to move this constant here, or the number that side, so that I just remain with the letter. Okay, so I'm going to have 5 limit x as x is approaching 2 on the numerator. On the denominator, because I've got a variable x, I can replace that x with the constant that we're approaching. We're approaching 2. So I'm going to have 2 squared plus a 1. So on top I'm going to have 5. Now this is a variable. Okay, so we're going to replace that variable with the input value that we are approaching, which is 2. So I'm going to have 5 multiplied by 2 over 2 squared down, that is just a 4, plus a 1. Okay, then 5 multiplied by 2, that is a 10. A 10 divided by 5 down, that will just give us a 2. So this is how you solve these limits. Okay, now you can also have a power. What if you have a power? Okay, what if you have a power, or what we call an exponent? So how are you going to solve that? So let's say you have the limit, let's say of f of x. This f of x, let's say it has a power. Okay, let's say as x is approaching a, what you are going to have in this case will be the limit, you know, of f of x as x is approaching a, everything to that power. Okay, so now the power in this case should be a positive integer. Okay, the power should be a positive integer, not a negative one. Okay, so that is very important for you to know. An example I can give on this one, let's say you have the limit of let's say 5 over x squared as x is approaching, let's say, a 4. So what you're going to have in this case, you're going to have the limit of 5 as x is approaching 4 divided by the limit of x squared as x is approaching 4. Now what are we going to have? The limit of a constant on top, it will just be the same constant, which is 5, over the limit of x squared. Where there is x squared, we are going to replace 4. Okay, according to this rule. And that 4, what you are going to do, you are going to put the power. The power in this case, it is 2. Okay, so you just have 5 over 16, and that will be your answer. So this is very important for you to know. Now what if you combine, let me say you combine operations. Let's say you have the limit of let's say x squared minus 5x plus 6. Let's say as x is approaching, let's say 3. So how are you going to solve this one? Okay, so you're going to also separate. You're going to say the limit of x squared as x is approaching 3 plus, oh, this is a minus, so you have a minus here, so you're going to write your minus. Then you find the limit of 5x as x is approaching 3. Then we have a plus, so I'm going to put the plus here, plus the limit of 6 as x is approaching a 3. So now how are we going to solve that? Now this is a constant, this is a letter, it's a variable, so we're going to replace that variable with 3. Okay, so we're going to have 3 squared. Okay, we have a minus here. Now we have a 5, so we can bring the 5 here. Okay, so we're going to have 5 limit x as x is approaching 3 plus, now the limit of a constant on the far end, it is just a 6 in this case, so 3 squared, that will just be a 9. Now where there is x in this case, we're going to replace by 3. Okay, so we have negative 5 multiplied by a 3 plus a 6. Now we have 9. When we multiply that, that will just be negative 15 plus 6. 9 minus 15, that is just a negative 6 plus 6, that will just give us a 0. So this is how you solve these limits. Now sometimes the limit cannot exist. Okay, so rule number 5, a limit that does not exist. So a limit will not exist. Let's say the limit of f of x over g of x as x is approaching a, and in this case your a, let's say you have a and b, and your a over b, let's say f of x is a, g of x is b. In this case your a should not be equals to 0, or let's say your a in this case is not equals to 0, and your b in this case is equals to 0. Because the denominator is a 0, it means that limit does not exist. Okay, let's solve an example. Let's say you have the limit, they've asked you to find, let's say, the limit of let's say 1 over x, or let's say the limit of let's say x over x minus 5 as x is approaching, let's say, 5. So what are you going to do? So it means wherever there is x, you're going to replace a 5. So in that regard, we're going to have 5 on top divided by 5 minus 5. Okay, in that regard, you're going to have 5 divided by 0. Because you're dividing by 0, this limit does not exist. Okay, it doesn't exist. However, what if you've got the limit of let's say you have a quadratic, x squared plus 10x plus a 25. Let's say this is dividing by x squared minus 4x minus 5, and in this case your x is approaching 5. How are you going to solve this? So yes, you can try to replace 5 throughout, but because this is a quadratic, simplify it further so that first you get the answers, then you substitute. Okay, unlike the previous one which was already simplified, this one you have to first let's say simplify. Okay, and when we simplify the one that is on top, so the product, the sum, and the factor for the one that is on the numerator. So the product, you're able to see that it's just a 25. The sum, it is just a negative 10. Two numbers that when we multiply them, they'll give us 25. When we add them, they'll give us negative 10. So negative 5 and negative 5, they are going to achieve that. So therefore, on top, we're going to have the limit as x is approaching 5. On top, we're going to have, when we simplify that expression, we're going to have x minus 5, x minus 5 divided by, let's come to the one that is down, the product, the sum, and the factors. Okay, now the product, you're able to see that it's a negative 5. The sum, it is a negative 4. Two numbers, when we multiply them, they'll give us negative 5, but when we add them, they'll give us a negative 4. So what are those two numbers? A positive 1 and a negative 5. Okay, yes, they will be able to achieve that. Therefore, down we're going to have x plus 1 and x minus 5. Now that we've got this expression, you're able to see that we can divide x minus 5 and x minus 5, they'll divide. Now that we've got this scenario, we're going to have the limit as x is approaching 5. So where there is x, we'll be placing by 5. So I'm going to have 5 minus 5 on top over 5 plus a 1. I'm going to have a 0 over a 6. 0 divided by 6, that is just a 0. So this limit exists. Okay, limit exists. Okay, so this is how we are going to solve limits. Now, limits can also be solved using what we call a piecewise function. Okay, okay, so a piecewise function, mostly the way they're going to ask you is, let's say you have f of x. They'll give you, the values. Let's say x squared, you have, let's say, negative x plus 6. Let's say on top x, the domain x is less than 2. Let's say down you have x is greater than 2. Then we're told to sketch number 1. Number 2, let's say they ask us to find the limit of f of x. Let's say as x is approaching, let's say 2. Okay, so how are you going to solve this? First, you have to sketch the graph. Now, you know how we sketch piecewise functions. The videos are there on how to solve piecewise functions on YouTube and on the drive. You'll be able to access those ones. So you have to plot this graph. Okay, if we are going to plot the graph of the first one, x squared, let's say we're dealing with x squared. Okay, since x is less than 2, we can start from the same 2. Okay, if x is 2, let's say x is 2 here. Okay, what are we going to have the value of x? X squared will just be, or 2 squared will just give us a 4. Okay, let's say our 4 is there. So this will be the point. But now, am I supposed to shade this point or just leave it like that? Now we're able to see that x is less than 2. Therefore, I'm just going to put a circle here. Okay, let's say because x is less than 2, so I'm going to be getting values that are less than 2. So now let me say 1. Okay, if I put 1 where there is x squared, that will just be 1 squared, which will just be a 1. Okay, so I have a point 1, 1. Let me say 1, 1 is here. Let me say my 1 is there. Okay, then let's put 0. So if I've got 0 where this, I have a 0. So I have a 0, 0, which would be there. Let me say a negative 2 here. A negative 2 squared will give me a 4. So I have a point negative 2, 4, which will be somewhere there. Okay, so you're able to see that this graph for the first one, it is going in this direction. It passes through 0, 0 and is going like that. Okay, so that is your first graph. Now let's come to the second one. On the second one, we have negative x plus 6. So we can also come up with a table of values. Let's say this is x and this is y. Okay, now we're saying x is greater than 2. So because x is greater than 2, we can start from the same 2 and going to numbers that are greater than 2. So if we, in this expression, if we put 2, what are we going to have? If we say negative 2 plus 6, Negative 2 plus 6, it will just give us a 4. Okay, so the point 2 comma 4, okay, which is the same area. But now, am I going to shade this or not? I'm not going to shade it because x is just greater than 2, okay, meaning 2 is not included, so I'm not going to shade it. I'm going to also put a circle here. Now let me come to the another area, another number that is greater than 2. Let's say 3. If I put 3, it will be negative 3 plus 6. That will just give me a positive 3. So the point 3 comma 3, let me say 3 comma 3, it is just a little bit down 3. Let me put another point like 4. If I put 4 there, I'll have a 2. So let me say 4 is somewhere here, so it will be somewhere. So this would be like a straight line. Okay, so this would be like a straight line like that. Okay, so now this is our graph. Now it's going to cut this point. It's going to cut this point, and that is at that point. So you also have to find that point. Okay, so this point will just be like 6. But now, what is my main interest here? So the way I'm going to find it, we've sketched the graph, we've solved the first part. Now how are we going to find the limit of f of x? Now you know that you can approach the limit both from the negative and the positive side. Okay, so what are we going to do? So let's find the first one. So we're going to say the limit of f of x as x is approaching 2. Let's say it is approaching this 2 from the positive side. What is going to be the answer? So you're able to see that this limit, as it is approaching 2 from the positive side, okay, like that, you're going to this point. That point, it is 4. Okay, so this is equals to 4. Now let's approach again this limit in the negative direction. The limit of f of x as x is approaching 2 from the negative side, you're going to have, so from the negative side, this is a negative, you're coming from the negative and you're approaching that point, you're able to see that again you're going to reach at that limit. Okay, so this is also a 4. Now what will be your conclusion then? That those are your answers. The limit, therefore, so you're going to say, since, allow me to rub on top, so your answer will be since the limit of f of x as x is approaching 2 from the positive side is equals to the limit of f of x as x is approaching 2 from the negative side is the same, or it is equals to 4. Therefore the limit exists. Okay, it only exists when you're approaching that point from both the negative and the positive side is equal. Okay, so that is very important for you to know. Okay, let's solve another question. Let's say you have f of x is equals to 1 over x. Okay, and they've asked you to find the limit as x is approaching 0 of f of x. So I'm going to do that. Let's say this is our graph, this is our y-axis, this is our x-axis. Now you're approaching 0 from there. You can either approach the 0. Let's say you can either approach f of x as x is approaching 0 from the positive side, and you can also have the limit of f of x as x is approaching 0 from the negative side. Okay, so what are we going to have in these scenarios? Let's say this is our y-axis, this is our x-axis. Okay, So if you're going to be approaching 0 from the positive side, okay, so you're trying to find the y value where it is 0. So you're going to be approaching the y axis in this direction, but you are not going to touch the x axis, okay, in this direction if you want to be approaching it from the positive side. Okay, then you can also approach 0 from the negative side. So this is a negative part, but you're not going to touch that line. Now you're able to see that this one is going to positive infinity and this one is going to negative infinity. So the limit on the positive side is giving us positive infinity, the limit on the negative side is giving us negative infinity, because since the limit of f of x as x is approaching 0 from the negative side is not equals to the limit of f of x as x is approaching 0 from the positive side, this limit does not exist. It does not exist. Okay, so that is very important for you to know. So that's what you are supposed to know on limits. See you in the next session. I'll be talking about derivatives.